So our last speaker is Joseph Bernstein, who will be talking about regular densities and differential operators for singular varieties.
So I played for it was interesting. So it was more interesting. Was in Moscow. Well, it was actually best. It is also the label I was seeing. It's and I can hear when it came. He's a but so you can kind of just don't have some interests. Okay, so I would like to talk about the best for this. This talk like and broken because what he did, he considered non-singular variety or get filled over anything. So you have a notion of smooth measures. To do singular variety. Does exist a notion of smooth measures and single variety? So I'd like to argue that sense.
Well, no, we've got an empty page. Press one.
Maybe maybe
It is, it's not. No.
it's all the dogs. The idea is that just a general idea of break others isn't to have very open some easy problems. It's a very tool. Was very correct. And somehow it's found and there's a very main of this problem, so it's such a great tool. So and that is appears on the way of us. So those step has evidence probably solution. So let's test the useful focus of very good. And it's going to say that the question issues. Is and more so it's so the idea is that if X is a final, so these are just A models. In general, dispute for A models, so all sources, which I will consider the qualification circles, that all symbols just in space of hybrids. So nice sounds funny.
Wrong direction.
So if X is constant, it has two important combinations of all things. Shift one S. A shift one events with densities of volume quotes. Usually when you get realizes shift of top differential force, but this is relevant. This the super manifold sets materializes. This is the subshift of volume force, which never put in densities. So I think that every stage is related. There's a natural canonical local construction that has the basis in model on against which involves a sheet of resultants. On the open there's set of smooth points. It's okay centers zero shift density state 4. So the way is that it has canonical extension to the whole sequence. Okay, so this was really notion of this. Anyway, that is a bit considered. There's also notion of smooth this. So this construction is non-trivial. It is based on the series models, and it is non-trivial as each strong sets and they can give you two, so they can give construction, but in order to compute this construction, even simple spaces, it's became not very easy. So this will have important implication. When this fish from algebra has that's like a small level that's this. And I mentioned was discussing for general question. What is the correct definition of differential data? So that is defined as the principal demands. So the construction is based on transforms. So if X is finals really created, A is algebra functions on X. Regular functions, and then the T divides the algebra differential operators, the effects, there's some algebra of end-line fields. But then here's a description, there's the difference. So usually say that there's some differential operator that convey those functions, eventually goes to zero. Here in definition is that you can consider the massive they think as a bimodal over algebra A, this is for this multiplication. This is model over algebra A tensor A, which is function on x squared. This function contains ideal which ideal there. And then the definition is that operator T and the matrix A, and A is model over B. And the rate of all the vessel equal to K, which is skewed by K plus first power of the cycle. And then the zero things as given TP. So now the definitions for using GLS, if you have any two models, you can define the notion of differential graphics from M to M. And especially if you have one model, differential graphics. Now for technical reason, if you want to localize this data, you have to assume the graphs five-versionated model. So this construction compatible civilization is model and science distributed. And as a result, you can simplify this construction and to enumerate X, given beginning to model M and quasi beginning to model M, then define the shifted differential homomorphism. Now, the definition works very well for smooth varieties. Ranges with more both systems variety locally, so all of specific studies that are locally, you can choose vector fields and vector fields, which take place all particles, differential data sets is given functions and polynomials of these vector fields. Okay, but it turns out that if you consider this definition of similar varieties, then it's not certain. So you will express this later. Okay, so now I want to remind some fantasy, some assertion. Facts about T models. Namely, circumstances whose variety. Again, I use both shifts and so on, but you can do everything just locally for one fine case. Wait, that's smooth variety. The model by definition is shift of left X models, it's classic against shift all models. The medium criteria will denote the model effects. It is also considered particular variety models. For example, the shift the model Y-X has a racial structure variety model. So in fact, this fact such as which is the level of shift is given by tensor properties or and this equivalence of materials for that model centralized model. So convenient way so convenient way to think about this is the one of the period symbols. And the restorations, realization, if left model similar to evaluation like right compensation, the later they go just not to have also back to pictures just in fine. So and the technical test we will mostly work with right models. And so the main result if you are going to Schwarz images very simple with this result. So the people with also have smooth variety X, smooth variety W, and X W is closed smooth subvariated. That the Schwarz lemma is a statement that the category of T-models on X can be initially identified as subcategory of T-models on Y, which is concentrated supposed to X, physically supposed to X. That's equivalence category. Then the experience is given with four factors, so that I X to W is no basic. Then I can consider shift. So X W is given by some shift of functions. So I can consider this model Gx W. And it turns out that this model is a bimodal over on left you can multiply by Tx, on right you can multiply by Ty. And then you find the factor from right T modulus on X, from right T modulus on Y, but it is tensor product. This is now you generate the idea sections of the dimension F. But this kind of small is that each section of F will open. Each section of F gives you section of star of F. Plus you can add tensions of the units in all directions. If you differentiate, say, tangential spaces, just differentiate along X, so you will have to know how to do it, and then you add this for all the features is how to think about this. So, but what's one? The Schwarz family is that it's the appearance of it is. So, and if the factor is given this home dxy to h, so if you have model which is on W, T model on W, which is double to X, you would like to accept T model on X. So he's the formula. This is exactly the thing, just from definition it takes W. You see that you just see the sections of each Hinsberg asymmetry. And then on this section, there's an actual that's okay. And now he is non-trivial. It's way to say it. Turns out that using Schwarz lemma, you can define category of G-models on its own any single variety without defining what is G-modulus single variety, what is varieties of single varieties. Maybe give the following things to support it to define. So X is defined symbol for it, try to define some categorization of categorizing models for X. I do transform P embedded closely into some defined smooth square double two. And then just declares the models of X, like the models of X. Are by definition the models on double relation constraint of X. Instead using Schwager lemma, it's easy to check. So if X is not similar to the Schwager lemma, claims that this thing will be treated as the same as the details models on it. Except the same means that this canonical is not simple. Now, if you think about this conception, that whether this is that you have to different in ways that this categories will be exactly that the people canonical efficiency. So that's the profile X, you can define this way, and then you can use that thing. So this to me is quite interesting things that you have some particularly if you don't really have some particular registration. Category is defined, but if you compare this category of shoes, well, then it is really they now same which visualize implies a have a canonical factor from for any single varieties. So it's similar to next, it will always next. Then you get it to define locally. So you have S applied variety, and they have the module selects. What is the module on this? It means they equate the text to some double. And they have the module as a double, which is supposed to next. Then I take so S is equated into double, so it's given as some zero G. And now I take kernel of the title in our model H. So that's what I have the model H states of double on double T double model H, which is the state from X. And I consider models in the state connection is that any section is hit by some power of G. Conditional positive things. So but it's just six rejecting by just shape. So this unit all X fold. And then again, the Schwarzschild immediately says that this doesn't depend on this factor doesn't depend on consumption. So, okay, now let us start towards all model one gates. So let's get this for today. Open that's specifically it's consists of a system of smooth spoons. You got the simple example blade of all smooth spoons. This one subset. Okay, so now we use a series of models. And the series of models that's usually called reverse extension of model threads. With some maybe here. We'll make some general. In general, it's the Smith is the following things. They have some topological space and have some views during that's of the subset. It's the coordinate subset. And suppose you have some object on U and you play to extend it to X. Some object, for example, you have a function on Q and you would like to extend it to X. So in principle, there are many ways to extend it. exactly can set by zero, but it's not interesting. But it turns out some conditions of that one, sometimes there exists some canonical exception. And some condition is some function on shift, there exists canonical exception. For example, in two examples, you have, for instance, if it's on plane and you have a function which is holomorphic, then it has holomorphic information sometimes. And it's very often you can prove that it's holomorphic system, but actually computer that is very different problem. So you can show that the system perception which for some functions, not all functions, some functions gives this. So it turns out that in the theory of the models, this kind of things, so if you have holonomic, so if F on X, holonomic the model for single model is that holonomic means that it's small. So since there exists canonical way to extend, so that it has several things which are several trivial ways to extend it. So some direct images, so-called direct images won't support, but suppose it's a trivial, so it's a non-trivial way to extend. And in mathematics, this is used very often. And that's what they would like to use. So
X is not necessarily smooth. X here is not smooth.
no, it's not smooth.
U is probably the smooth slope of the
Yeah,
function.
that's right. People consist of some slopes or some moments of that. That's
Or some sort of.
Okay.
so on U, you have what we do is the right model is
But this category is defined using open embedding locally is to smooth. Varieties. And so that's
interesting. So you have X as a single variety. In all that exists, then subset of smooth.
Yeah.
So for instance, so choose a U. That's the subset U. Now, the models of X are defined by some complicated procedure. You should embed X to some W, not immediately, and so on. Now, the models of Y also defined by this procedure. You can also define since on U. Since U is non-singular smooth, you can just consider just usual thing it's the same. So consider the omega U. So this is again, this is a complicated procedure. This omega U is just a naivety that interprets it as the model on U. Now, U embeds into X, so consider the system direct image factor. J star. Now, in order to fastest, you have to, since the answer you get in the models of X, you have to recall these assumptions that you should embed the X, some W, and so on.
Yeah.
So it's not trivial. So it's not just something very trivial, just differential form, sheer differential forms, whatever, normal forms on you. But just the answer, but actually you have to come close. Okay. Okay, so this is very crucial. And this is this procedure how this is very crucial. which is the modulus of x. Again, the modulus of x doesn't have capitalization. It's considered. And one of the facilitations shows it doesn't. Okay, now, even what government models, that they are very small, is this that implies that there is also government. And it's very small in the sense that it's finite facts. If it's finite facts, then the play it has minimal submodel, which is fixed to you in our original shape. So this is basically procedure.
Can I ask a question?
Okay, and so we divide models, presentation, starts sheet of all people, which is a minimal submodel of this guided image.
So
Okay, so
you have not just quasi-coherent sheet, you have a demodule.
no. So I didn't. So I didn't understand. That's the part of the sudden okay, well, that the status was on visual.
You start with omega u, you push forward using this intermediate something.
No, not intermediate. So I said it's intermediate. And it's just support. And it's a
Okay, you push forward and take
on
meaning
X.
of that module. Okay.
And that the model has finite legs. For
Mhm.
this reason, you could take.
So at the end, you get a D-module, and that you
Yes.
get D-module structure.
No.
No.
Like this one.
I haven't finished.
Sorry.
It's just I haven't finished. Okay. That thing is that I just no.
You apply this functor that you described before. Yes.
No. It's was it
In the previous slide, you described this functor. I don't remember the name.
Ah,
Yeah.
yes.
Does T map holonomic to coherent?
For any x equal to 4, single, we define parameter for right. So the models are next to sheets on all models. It's kernel of shape. In case where s is not singular, this is something that if you just say
So for singular, it's not just forgetting the structure, right? Well, there is one.
So, okay. It's if you consider case of S is not singular, you can identify category of the models, it's just usual category of the models.
I understand.
And then you'll be just forgetting the structure.
So still, T plays the role of forgetting factor, no?
Yes.
Okay.
But so it doesn't map holonomic to coherent, yes. Joseph?
Okay,
So T does not map in general holonomic to coherent.
what
T does not map in general holonomic to coherent.
Of course, no.
So the result can be not coherent.
in our case, it should be in principle, so it's your bad.
And is T exact functor?
So this answer is correct, etc. But not exact. So in this case, focus should be but it's
Sorry. Does this omega x defined in this fancy way, is it connected to the dualizing complex?
They've got it.
is interesting question because what do you mean with the lesson complex?
They got
Well,
it.
this is a good algebraic variety. You have
So first of all, The claim is there's no theory for single varieties, there's no good theory of the rising complex. So in fact, the rising complex lives not in category of classification models, it lives in category of integrating models. That's
Okay, yeah, but
so all this, but okay, I don't know, but just
okay.
the claim is that in systems, theory is not really well developed answers. Well, it's very nature question, which maybe does, maybe again, except that when you consider the amazing the sheets of dimensions, here it's don't consider sheet dimension. Okay, that's so okay, so it's the base of construction. Now, just if you look at this construction, it is dependent English. It is a presentation series. You have some category of presentations, things you would like to describe irreducible objects. It turns out the standard way to describe irreducible objects starts at the representations of symmetric groups. Is the form you describe some objects which you understand. One object which you understand is called basic, or basic in morphism of one to another, and you can see the image. So you can describe it in this case. As a result, you do some summations. So to understand for instance, some character of this thing and so on, it's very difficult.
Okay. You have to go because otherwise we won't hear the end of whatever.
No.
Normally you have, I don't know, 15 minutes or something.
Okay.
What is it?
That's feature. So I,
Of course, of course.
so I formulated the problem with the
Also important to them.
Yeah. This is the line extension, and describes the scaling extension. Then I put describes some kind of applications. For example, smooth regular densities. So spell varieties definable are consider space of its real points. This is singular space, but let's assume that smooth points are depth of space. Now, basically, it's a smooth variety, divide the shape of smooth, but it's clear with shape of smooth functions on y. This natural structure for models is then for any or model H, you can define shape of smooth sections of y on this page. That's the code. In particular, we define on y, we define the shape of smooth regular densities. So if you have real single variety, there exists a canonical shape of smooth densities. On smooth part, it is just usual densities. But on single points, they have some very explicit behavior, which is not easy to describe.
So I'm sorry.
Now,
Could I ask a very neat question? So if your singular variety is a fiber of a polynomial map, then in the setting of Rami-Stock, you have a canonical, you have a naturally defined shift on this fiber by kind of the what Rami called Gelfand-Lere. Do you get the same? Do you get the same? Is this the same? Is this the same shift?
it's always not.
Probably.
This is exactly the shift that Rami was talking about.
So, again, my claim is that this the construction of reverse extension is highly non-trivial, means that it's very difficult to
Understand.
actually spread what is.
Gelfand-Lere is also not.
It's much more complicated than direct image. That it's different level of
Gelfand-Lere is
so
also
maybe so.
conditional measure.
If you ask me, I say the problem is not.
Is there an example, is there an example which you can compute? Is there an example of a one-dimensional singular variety for which you can compute it? Yes.
At least.
Okay, not here.
Okay, let's spread in a moment. Okay, so Google sections of the schema are just smash volume functions of a set which have some criteria that specifically the single points. And the analysis of the six is gives some information about the data. So why it is important because in many cases there are for instance, in case which I know pretty well, so what's first interesting part in your case of simple variety? Because in quadratic form, it's undimensioned. Dimension 3 equals 60. So it's not singular anywhere except 1 point. So you get some volume forms in single part, which some way explicit expressive behavior and so. So this is the place which so why is it place of Schwarz space of this? So why it is because it turns out that the fact you consider this A2 functions on your own. Then there's an action of much larger group, a total group of twice small dimension. And then you can consider small surfaces. And this is exactly the Schwarz space. So this is some very interesting subspace, which we should all the space of Schwarz functions of this.
Can I ask a question?
Yes.
So you described that this space of Schwarz function is a tensor product of usual Schwarz functions with an O model, yes? So you say that Schwarz sections of
You
use
know,
model.
like Schwarz function on a regular function, I can't understand.
Yeah. So you define it as a tensor product of you start with defining O model, some tricky O model,
Yes.
and then you tensor it with smooth functions.
Yes.
So the sections going to be combinations of sections of the O model with coefficients which are Schwarz functions. Yes.
Yes.
But the O model, you say that on the regular locus, it has to be just smooth dog forms.
Yes.
But since it's normal, it's defined like there's no like it has to be just smooth forms, no?
Yes. On simple. Okay. On the non-single path, it's just small forms.
But I claim that over O.
Question is what is zero.
But I say that over O, the behavior outside zero determines the behavior at zero. There is only one. There's only one possible behavior. So if you take two smooth forms outside zero, the ratio going to be a regular function.
No.
Outside zero, but it means that it's regular at zero.
I didn't say this. Okay. You misunderstood.
Okay.
I say that this is just I don't know. Reason what's why I can consider basic graphs. But functions have smooth outside of zero and still have two sequences x 1/2 and x 1/3.
But line, yes. But line is one dimensional. But line is one dimensional. I think if you have singularity of codimension 2 and you have O module outside this singularity, so okay, there's more than one way to extend it, of course, but somehow all the other way will be supported at this point. No?
So I say that this is an index space issue. In this equation, so that describes this space. So it means that by hands it's very easy just even to describe what is the space called. It can just okay, so now the plan is that you can here everything for you now is but the plan is that you can have to say for yes. So if you have it's a little motion smooth, that's for instance in the case of one, this is that's smooth outside the zero, it has some structure theory, some great continuous structures. So my suggestion is to go out with it because you consider your case. So because the thing is that I lost the whole thing here. Okay. And now it's just the last thing. That it's based on your word transformation. You can also consider the recursions. So your regional field is global field, for instance, field, and you can see that just at all places you have this one, so then you have some Gregg pitch. Oh, by the way, because my consumption doesn't look in characteristic field pages. Of course, characteristic, but my still suspicion is that subsequences should be there. So this is a subsequent committed X, but I have no idea. Okay. I'm also interested in this computers like, okay. Maybe if we use the definition, which is if X is very smooth, the definition probably then the definition goes if X is not smooth, formally terms, it gives you some classification. But this classification is not good. What does it mean? That's suppose that C is a component C3, for instance, S3 plus 5 impression C2 is equal to 0. Then the probability of X is bad, it's not material, not by detriment. So, after the talk about it means that there's no such function on singular. This is notion at all. There's no notion of the model. Differential. But that does mean that there should be notion. I prefer another answer. The such notion probably exists in many cases at least. Just this definition gives a wrong answer. That's okay, and I have even some conceptual answer. So suppose SCP doesn't involve say useful find complex variety. Consider all of the polynomials should define default. So this is very complicated the model, all model. And then define correct notion differential data as such differential derivatives of this model. So the idea decided that all x is good for model. But it turns out that maybe it's not correct model, correct model is only x. And some varieties is exactly essentially the same as usual fixed because some varieties the differential probability of omega x is opposite to tx. It's means that omega x is right model, which means that the differential probability of omega x algebra is opposite algebra. So it's essentially the same.
But your omega x is the one that you can
Yes, yes, is the only one which you can imagine for single x. This is not some basis of the people. So if the projection is correct, then this is an indication that maybe the correct definition of differential is also
What do you mean by cubic common? X to the third plus y to the third? Quadratic common in three-dimensional space. Cube.
Yeah.
In n-dimensional space.
You know, it's his work with Gilbert.
Well, just issues, so people just people, but 50 years. Also, it's not Brasilien. But if you look at the proof, then you see that the natural force is not Brasilien, but it's close to the nice hospitals. You get them. Find some nice algebra which is okay, so I just prefer to use the correct option. So that's
So in your head, this is a subring of quadratic ring.
yes.
Subring,
No,
because I thought maybe it's extension.
so let's consider this should
So for this case, you have just computed completely the ring, and
yes.
you're interested in,
Yes.
and it is subring.
So
But you're not sure that it's general situation.
How is the
all of varieties is
Okay.
it should be something.
Mhm.
So if you have differential derivative, then on spice also gives differential derivative. Spice is a usual differential derivative, then they will be together. And if we give you differential derivative,
So in your philosophy, not everything actually can be accepted.
yes.
Okay.
So
Okay.
Are there more questions?
no, so okay, so I conclude that my philosophy is that once you know the direction, it's my options and not
Okay, yeah.
this is for again.
Okay, it's for you.
More correct.
For me, I want to have a nice algebraic definition. So,
Or come on.
it doesn't come from-
So I do have another question. When you say that this should give the correct answer, so you conjecture that the category of D modules will be just modules over this algebra, or it's too much to ask?
I don't know.
But there is no such some reason to believe that there is no algebra such as this category of. So this category might have projected generator, or you don't see a reason why.
It's great. The patience was very correct. It explains it's very correct, it's not very good. It does take also. If it's given, in principle, you get the idea that you have and you want to realize that the models somehow should. So that's present even if I don't look. That's very good. And this story using algebra.
But
So everything else will give you different things. But so also this also some projections also. And category models of this algebra is category of subgroups. This doesn't mean that the algebra is
is a correct answer.
yeah.
No, but even so you don't have some example or some reason to think that there is no such algebra. For a fine case. No,
So
okay.
what I was very fine. Okay.
We don't kill a push.
What's the Thank you.